Welcome back to week 8 where we are discussing tides. This is our final video, video 3 for this week's material. And what we're going to talk about are some of the causes of tides. I mentioned in the last few videos that we have to know about the Earth, Moon, Sun system to be able to predict tides, because that is what causes tides. So to get into more detail, basically, we have this gravitational interaction of the moon with the Earth and with the Sun. The size and rhythm of these tides are dependent upon your latitude, shape of the basin, and the coastlines, and the time of the month, and the Earth's rotation. Lots of factors that go into the causes of tides, and also need to go into these models that predict tides. So, pretty complicated systems. If you guys want to do the math, I've got a little figure here from the NOAA website. Basically, the reason why we get tides is because of the gravitational force of attraction between these huge, large masses, the moon and the sun. Now, because of the sun's size, you would think, oh, the sun's got to have way more of a pull on the Earth's tides. Well, that's not the case. The sun is so far away that because of its far distance from the Earth, the effect on tides is much smaller than you would think. It's about half. The moon is so much closer, even though it's a smaller body, it's so close that it affects the Earth's tides much more. And it's really based mostly on where the moon is located in relation to the Earth. So the moon is what really drives those tides the most. So when we take a look at this Earth-Moon system, we've got the Earth, and of course the pink area, the tidal bulge, is widely exaggerated in this image, but you get the point. So Earth is sitting here, the moon's on the right. The gravitational pull towards the moon creates a bulge of water on one side of the Earth, like a wave basically, and then you get a second tidal bulge on the opposite side due to inertia. So we get a near side and we get a far side bulge on either side of the Earth, which is why we have two tides in some locations, one high, one low. Or sorry, two highs and two lows in some spots. So we get two bulges, and this is why we've got these 12-hour cycles in a lot of locations, because it's on the other side of the Earth. I mean, Earth rotates in a full circle in 24 hours. So we have these two bulges, one due to the pull from the moon and the other due to inertia on the opposite side. So these images that I've been showing you come from this NOAA website, and we're going to take a look at some of these animations showing how that tidal bulge moves with the moon, looking at sea level in relation to where the moon is and where the Earth is, and then spring and neap tides. So pull this website up here. It's the NOAA Ocean Service Education site, which is great. And this section is all about tides, so if you're looking for additional information, great website to check out. So if I center this a little bit better here, what we see is we've got the Earth here, you got north, south, the equator, and you can see the moon rotating. It's not rotating that much in this picture, but going from about 30 degrees down to 0, and you can see how those tides, both the tide that's pulled towards the moon and the tide produced by inertia on the opposite side, both of those are rotating around the Earth. So we see these bulges track and follow the position of the moon. So knowing when the moon is going to be where is a big factor in knowing when you're going to have your high tide where. It's pretty neat stuff. So the second link I want to show you is on the same website, the NOAA Education website. Here we've got one position, so this picture that we see down here in the bottom with the land surface and the water going up and down is at this location here where the blue line is sticking out from the Earth. So when we come around and we are facing the moon, high tide, we move around 90 degrees, low tide, around 180, high tide, around 270, low tide, and then back around 360, high tide again. So we get our lunar day lasts 24 hours and 50 minutes, so slightly longer than our solar day. So this is why the tides aren't at the exact same time every single day, because the lunar day is a little bit different. It's a little bit longer. And the moon is revolving around the Earth, and it takes an extra 50 minutes to catch up to the moon. So we see the Earth rotating through 2 tidal bulges every single lunar day. So when we say lunar day, we mean this 24-hour, 50-minute cycle, almost 25 hours. So we end up seeing these high tides about 12 hours and 25 minutes apart, and taking about 6 hours and 12.5 minutes for the water at the shore to go from high to low, and then from low to high. So these places that have the huge tide ranges, that tide is changing. That 45, 50-foot tide in the Bay of Fundy is changing in 12.5 minutes, that 50 feet. It's an astounding amount of time. It happens incredibly fast. Pretty amazing stuff. So that's our Earth tide system. And then here we can take a look at spring and neap tides. So here we involve the sun in this rotation. Let me just make sure that we can see this. So we've got the Earth in the center. We've got the moon in dark purple, sun in yellow. And you can see that arrow on each of these sides is showing you the different tides on the Earth. So we have lunar tides in pink, the tides that are pulled towards the moon. And then we have solar tides, which are pulled towards the sun. And you can see they're very different. The sun tides are much smaller than the lunar or moon tides on the Earth. So when we watch this rotation of the moon, Earth system, and then the sun, when we have both of these tides lining up together, we have really, really high tides, which we call spring tides. And those happen twice in one of these rotations. When we have our lunar tide and our sun tide not corresponding to each other, opposite one another, we have what are called neap tides. So our tides are a little bit lower. So spring tide, higher tides, neap tides, lower tide. So when we get to that right angle, so here they're parallel, and then we're at 90 degrees or perpendicular, parallel, 90 degrees again. So that 90-degree side, we get this somewhat of a cancellation of these tides, which is why things get to be lower in those locations. So during each lunar month, we get 2 sets of spring and 2 sets of neap tides. And when you guys do your homework this week, you're going to take a look at some tide data and determine which days are the spring tides and which are the neap tides, based on when's the highest. Highest is going to be spring, lowest is going to be neap. So remember that. You guys can visit that website more on your own if you want to check it out. And then just to show you here, another image that's on that website, so showing the sun, the Earth's orbit around the sun, and then we've got the moon rotating around the Earth. So we have this elliptical orbit around the sun, and then this slightly elliptical orbit of the moon around the Earth. So once a month, what we call perigee, is when the moon is closest to the Earth, and we have really, really high tide generating forces, or higher than usual. So they produce above average tidal ranges. But 2 weeks later, what's called apogee, is when the moon is furthest from the Earth, so our tide force is much smaller. So perigee, closer, so we get higher tides. Apogee, further away, lower. So the closer that body is to Earth, the higher the tides, the more pull we have on those oceans. And then when we have the same kind of effect with the Earth and the Sun, so when the Earth is closest to the Sun at perihelion around January 2nd, more of a pull for our solar tides, and then the opposite, further away at aphelion, when we have the Earth further away from the Sun. So tide ranges are reduced. So it's just another way of looking at the Earth-Moon sun tide cycles. So when we talk about these spring, neap, semidiurnal, mixed tides, well, what kind of tide do we have where is the question. Who has diurnal, who has semidiurnal, who has mixed tides? So on this graph here, I've got the three different types of tides. So you can see the diurnal, one high tide, one low, semidiurnal, two highs, two lows, and then mixed, two highs and two lows, but they're both at different heights. So very different highs, very different lows. And on this map here, our diurnal tides are in yellow. So you can see where those yellow diurnal tides are located. Close to the poles, in enclosed areas like in the Gulf. Semidiurnal, where you have two highs, two lows, would be the east coast of the United States. Also, much of the Pacific, actually, a lot of that has these semidiurnal tides. And then when we look at mixed, we see a lot of the Pacific has some of those mixed tides, and then a little bit of the semidiurnal. So we kind of mix it up in these oceans. So where we are, we've got mixed semidiurnal tides. And on the east coast, opposite side of the country, semidiurnal. So very similar highs and very similar lows. So that kind of wraps up. You guys can check out GeoAtlas for more information if you'd like. So that wraps up tides. So you should hopefully know what a tide is, how they behave, the three main types of tides, the mixed, the diurnal, the semidiurnal, how tides are measured and how they're predicted, and then the cause of tides, which is pretty important. So make sure you review some of those figures that I showed you and animations, and take a look at some of those things in your book too, because those will be very, very helpful for when you go to do your homework and also for when you take your quiz. So I will see you in lab, or I will see you next week, depending on which term it is. So I will see you next week in week 9, Marine Life.